I'm Luke Rockers, and this here is Rachel Nichols. You say hi? Hi, awesome. And we are part of the graduating class of Oak Mountain in 2017. They say go Eagles. Go Eagles.
Yay!
Yay! When Rachel was born, she suffered a major brain hemorrhage. Until she was almost 2 years old, the doctors believed that her developmental delays were a direct result of the stroke. It was not until her parents decided to have her DNA tested that they realized she had a very rare chromosomal abnormality that was the cause of her mental and physical handicaps. Fortunately, our school system has an excellent disabilities program, and Rachel got to be a part of regular inclusion classrooms beginning in kindergarten. She was my classmate in 1st and 3rd grade, and she was able to participate in most of school's activities, like square dancing and the Special Olympics. Rachel and I even had fun at the 3rd grade sock hop. Time has flown by, and we are now wrapping up our senior year. This fall, I will be attending the University of Alabama, where I'll be doing genetic research with a computer-based honors program. There, I hope to be able to find out how each gene works and what role they play in each genetic disorder, such as Rachel's. Today, I'll go into more detail about the genetic disorders and explain what happened to Rachel's chromosomes that caused the abnormality. A genetic disorder is a problem caused by one or more abnormalities in the human genome. There are 2 ways that a human can inherit a genetic disorder. 1, the parents can carry an undesirable trait in their genes and pass it on to their kids, or 2, a spontaneous mutation can occur during meiosis. Meiosis is a name used to describe the cell division that the egg and sperm undergo when they are developing. Normally, meiosis splits the chromosome material so that each parent gives 23 chromosomes to a pregnancy. Chromosome abnormalities can occur as a result of error in cell division during meiosis. It's important to know that genetic disorders increase with the age of the mother. Women are born with all the eggs they will ever have. Over time, there are fewer eggs available in the ovaries, and they are aging. If you are 35, then your eggs are 35 years old. Aging eggs could possibly have the incorrect number of chromosomes at the time of fertilization. So the risk for having a baby being born with a chromosome abnormality increases with the age of the mother. So how do chromosomal abnormalities appear? In humans, each cell contains about 23 pairs of chromosomes, for a total of 46. 22 of these pairs are called autosomes. They look the same for both males and females. They are numbered by their size. The 23rd pair is called the sex chromosome, and they are different between males and females. Females contain 2 X chromosomes, but males contain both an X and a Y chromosome. This is a karyotype. It shows 23 human chromosomes lined up in pairs. The karyotype in this slide depicts a healthy boy, since each of the autosomes have equal pairs and there is 1 X and 1 Y chromosome. A chromosome mutation occurs when there is a missing, extra, or irregular portion of a chromosome. It can be from an atypical number of chromosomes or a structural abnormality in 1 or more chromosomes. For example, Down syndrome babies have full trisomy 21, which simply means that they have 1 complete extra 21st chromosome. Duchenne's muscular dystrophy is another genetic disorder where you are missing genes on the X chromosome. It does not alter or make the chromosome look any different, so you can't tell if a person has Duchenne's by looking at the karyotype because the disease karyotype looks just like the normal one. You'd have to have a genetic testing done to identify this disorder. Now let's look at Rachel's karyotype. Rachel's abnormality is more rare. Her karyotype depicts a little bit of an extra 13th chromosome referred to as a partial trisomy 13. Partial means not a full chromosome, like it's Down syndrome. Trisomy, tri, means 3, or referring to an extra bit of a 3rd chromosome, 13, referring to the 13th chromosome. In addition, Rachel is missing some of her 21st chromosome, referred to as a partial monosomy, 21. So Rachel is missing a piece of a 21st chromosome. But even more rare is the missing piece of the 21 is reattached to the extra 13th, which is called a translocation. This realignment of parts between 2 non-homologous chromosomes joins 2 otherwise separate genes, resulting in important genetic effects, as seen in Rachel. Genetic disorders affect an estimated 12 million Americans and over 300 million people worldwide. I believe that this should become a priority of scientific research in the coming years. After my undergraduate and graduate research, I hope to go out in the world and teach people about genetic disorders and explain to families their chances of inheriting them. But for now, it's off to high school graduation.